Okay, so this chapter is related to the electric field. Okay, so what they mean with the field, electric field. So they have a few terms or few concepts you need to know. Okay, besides that, you also need to know a few formula. So most of the thing based on this chapter will be covered up on the calculations part. Okay, maybe theory is slightly less, but you have more calculation.
Miss, you are muted.
Oh, okay. Let's start back. Okay, let's start back. So this chapter based on the electrical field. Okay, the one we taught you in the earlier section is based on the electric quantity. Okay, so some of the things that you need to know based on the not equation is based on the quantity, the formula or the scientific engineering equations or the unit that you need to know. So this topic is more to electric field. Okay, so when I say field means a few terms that you need to understand. Okay, so based on the concept, based on the principle, okay, based on the electric field. Okay, and we don't have on this topic, we only have a calculations part, more calculations compared to the theory. The same goes to the previous chapter, is more calculations compared to the theory part. Okay, so let's start. Okay, in this image at the first part here, you may have a look.
Miss, you muted again.
Okay, why is it mute again? All right, so let's continue back. Mhm. Okay, so you may have a look on this image first. Okay, this image showed one small girl, one is slightly average girl here. Okay, so they when they touch to the zinc, what happened to their hair? Okay, based on the photos there, what you can see. So usually this, okay, you can see like a hair spike up, right? Okay, and why is it happens? Okay, one of the things we call as an electrostatic. Okay, the terms or the things based on the field related is based on electrostatic. Okay, what they mean with electrostatic? Okay, we have a positive and we have the negative. So what they mean with the positive with the negative is related back to your atom. Okay, what they say based on the atom, positive atom or we say as a negative atom. When they say positive atom represent based on the positive ion. When they say negative, it means represent based on the ion, negative ion. Okay, based on the demonstrated with the electrostatic generator. So this shows you what happened to the person here. Okay, and where we have based on the atom. Okay, the mystery of the atom, that electron negative and also the nucleus positive attract each other. Okay, this is attraction called electrostatic force. So what they try to point out here is means when you have two atoms in a different how to say a different ion. Okay, we always say positive ion, we always say negative ion. So when we have the positive ion, okay, automatically the negative ion will be attracted. So that's the one they said they're using the word attractions here actually. Okay, you should have different ion, then only you can be attract. If the same ion, okay, example electron with the electron or positive ion with a positive ion, okay, so or we say as a proton, okay, is not going to have a electrostatic going to happen. Okay, so it means we should have a different ion, okay, in terms of the ion, positive ion or negative ion. So the word they're using here is attractions, okay, based on the force. All right, so later on they have an image here based on the charge. Okay, I'm not going to repeat back based on your learning outcome. The same thing based on the concept of electric field. Okay, and the terms that you always have based on the electrons, based on the Coulomb's law.
Miss, you have been muted.
Okay, I guess someone mute me, is it? I don't know why is it. Okay, I hope won't happen again. Okay, don't mute me. Okay. Miss, someone is removing me from the call. Okay, who is it? Okay, please don't play on this time right now. Okay, because we only have 1 hour. Miss want to catch up. Okay, because this is only a short topic. So I hope we can finish up the topic. Then we go with the discussion, some calculations. Because most of the thing based on these two chapter is related to your calculations. So most of the thing you will understand when you start to do a calculations. I hope this class, okay, my students can cooperate with this one. Okay, don't kick out anyone here. So someone was kicked out, is it? Someone is removing me. Who is it? I think everyone's here. Don't play. Okay, so let's start back. Okay, just be patient with me. Okay, we just have a short topic. Actually, this one is short topic. Most of the thing Miss just want to make an introduction based on the equation or based on the formula. Okay, so don't mute me. Okay, please don't mute me. Don't remove your friend. Okay, so the next one is based on the primitivity. So when they say primitivity, is based on the material actually. Okay, all right, so that's the one we have in the terms that you always use like a key term. Okay, we say as a key term or key point. Okay, even though when you want to explain something, you want to elaborate, or Miss asked you to, okay, please describe for me the definition, or I ask you to specify what the definitions for positional differences, or any the basic one, electrostatic example. So you can explain based on the key point. So as long you have the key word, or as long you have the key point, you have the marks there. Okay, marks means later on for your quizzes. Okay. So then the outline of this one is most of the thing they were going to cover based on the electrostatic phenomena, okay, based on the induction, and also electric force, okay, and also the field. And the next one based on the law, okay, electrostatic law. They have equations or formulas, okay, and the same things they have a concept for electrical field strength, which is based on the formula. Same goes for the electric flux, the intensities. They also have a formula, okay. Let's see. Okay, this is some real life. Okay, what they mean with the phenomena based on the electrostatics here. What will happen when you bring a mic to a charge of the zinc here? Example. Okay, a pillar. You can see like a pillar here. Okay, but this is a zinc one. So what will happen? Okay, and the next one is based on the real life. What happened in a real life? Okay, so just have a look on the picture first. Okay, maybe you don't understand the term. Okay, maybe you don't understand the point. Okay, just have a look at the image. You may have some idea on that. Okay, so the first image they just shows you a baby, a child here. Okay, when you go through the playground, the part here, okay, like a holes here, and you can see the hair was spiked up. Okay, so the second one is based on the comb. What will happen to your comb when you comb your hair? All right, so what they try to point out here is based on the electron. Everything is based on the charge. Okay, so for example, the one they explained it based on your slide, remember, the key point or the sentence in your slide is just a theory part. Okay, you can explain based on your understanding. Okay, as long you understand, then you explain it. Okay, don't exactly follow based on your slides here. Okay, the slide is just a theory. They just give you what is it. Okay, so you can explain once you understand. All right. Okay, the first one they just let you know based on the atom. Okay, electrical neutral, what will happen. So based on this part, they just specify for you the numbers of the positive charge. And also remember, the positive charge also represent as protons. Okay, sometimes they use the word ion positive. Okay, sometimes they use the symbols of the positive here. Okay, at the same time they also use the word hole. Okay, this one you may find later on in a semiconductor chapter, but they also can use the word hole. Okay, represent as a ion positive. Okay, but in this electrostatic we use the word of the positive charge. Okay, plus one, this one, the circle one. And where it shows you the equal, okay, they use the symbols of equal, the numbers of the electric charge. It means electron. So what they say, when you have a neutral electrical, your positive ion with the electron, positive ion with the positive electron, positive ion with the negative ion, which is stand for your electron, will be equal. So that's the time we say it's a neutral conditions, or we say it's a neutral mode. Okay. In the same time, when you have some electrons, okay, take note when they're using the word E with the dash here, it means it's a negative, or we say as an electron. Okay, are removed, the atom become as an ion dominating with a positive charge. Dominating means they have more positive charge. Majority charge will be in the positive. So that's the one they try to say here. Okay, and what happened? So the electrons are added to the negative charge. So indirectly, the negative electron moving to the negative part. Okay, in the direction of the negative. At the same time, okay, this is based on the densities of the electrons. Okay, based on the body. Even we say in the body we can have the electrostatic. Okay, you can make your hand. Um, okay, even when you try to comb, okay, even you try to rub your hand, then you try to touch something based on the different electrons movements, then you can see some changes happen. Okay, so this is a happen in a real life. Besides that, okay, this some explanations based on electrostatic. You may have a look hit on it. So let me go with the most one of the point that you need to know based on your electrostatic. Okay, so when they say atom is a positive or negative charge, it solely depends on the movements of the electron. So most of the thing you need to have a look on the charge movements of the charge. Okay, either sometimes they say, okay, the electron example, we assume this is an atom. We just assume this is a positive ion, and I just assume this is a negative ion. Sometimes you need to specify the direction or the movements of the electron. Okay, example, we say negative ion. So is it going to the left hand side, or is it going to the right hand side, or is it moving to the left hand side? You need to know the movements of the electrons. If the positive charge, it means it's moving to the positive right hand side or left hand side. So the movements of the ions is very important. Okay, because from there you will know the ion, is it attract, okay, to different ion or not. Okay, so example, you have the positive ion. Okay, it means moving towards this one. In my view, I say it's moving to the right hand side. Example, I have a negative ion, so it's moving to this side. So I would say based on the direction or based on the movements of the electron, okay, the one that's specific here, I will know this ion is attracted to this ion. Okay, positive to the negative. Okay, see one more part here. Okay, this is the same thing based on the electron and based on the proton, and also very specific based on the nucleus. Okay, and where the one we see in the circle form, they shows you in terms of the dash line. Okay, this line, the dash line, we also call as an orbit. Okay, and where we call as an orbit, electron carries a negative charge that is equal to magnitude to the positive charge of the proton. So where you can see they're using the word magnitude. Okay, magnitude to the positive charge, so they have some movement happen. Okay, beside the atom, we also have the energy gap to explain, but in our topic we don't have this one based on energy gap. The directions or the movements, how is it happens. Okay, and the next one is inductions. Okay, what they mean with the inductions here. Okay, in inductions we have sometimes the materials will be charged, sometimes the material is uncharged.
Miss, you are muted. Miss, maybe. Miss, I think got some problem.
Wait, okay, why anyone mute, miss? You want to take revenge, but this is not the time to take revenge. Okay, so you have other days to do that, because miss want to cover up based on this topic. Okay, I don't know, because I didn't press mute. Okay, even miss didn't do any restrictions based on your the students here. Okay, please don't do that. Mm. Okay, I just saw the text here. Okay, then Okay, so I hope you all can hear me. I do some setting here, so I think you can't speak to me. Okay, but you can write in your meeting chat. I hope I get removed again. Oh, who doing this? The setting is adjust. Same. Uh, who's the one noticed in our class? Hmm. The setting is done. I hope it won't happen again. But remove. Who did that? Okay, I will continue. If you have faced any issues again, let me know. Because the setting, I just changed the setting here. Okay, let's start. I'll continue back. I thought these class students are very smart students, very tolerate students, very understanding, very cooperation students. Okay, very excellent students. But why I having this kind of issues? All right, so I hope won't happen again. Don't play for this class. Okay, so just go on with the electrostatic inductions here. So you may have a look on this one based on the inductions part. Okay, we have also have one topic based on the inductor. Okay, and this one they just point out for you based on the amplitude, what will happen when your it's not body, it's based on the charge. Okay, based on the materials or based on the components they have here, where they're using the word body here. Okay, and where they have based on uncharged with the charged body. Okay, what will happen? Okay, and the same time we have also the positive with the negative. Okay, positive versus the negative based on the charge. At the same time, they also mentioned it based on the charge magnitude equal to the inductions equilibrium. So equilibrium means is a balance. Okay, they have a equal balance. So that's the one they're using the word these terms here. Okay, happening again, removed. Hmm. Means we have a child with us. Okay, but we did a setting here. Okay, those are removed here. You may join back. You may join back. Okay, because the setting was done, but it's not sure.
And you are muted.
Oh my goodness, I start the setting, but still can mute me. Okay, then all right. Miss, I don't think it's a student's fault. I think it's a problem with the Teams app because most of the people are facing it. Okay, I can't see the chat. It's empty. Okay, those having these issues, the one chat is empty. This is because the Microsoft team is updating. Okay, you need to restart your laptop or either you need to sign out and sign in back. Okay, log out. So you log out and then you sign in back to the team. So that's you can settle the issues based on the. Okay, Miss, I mute again. Someone mute me. Okay, but I think this is due of the issues based on the apps, is it? Yes, Miss done the setting because you can't mute me, but I think someone still mute me even I done the setting. Miss done the setting, but I'm not sure why some of you was removed from the meeting. Mm. Okay, I was reported this problem because but they. But some of them are still not in the attendance, I think. Okay, because they accept the meeting. So that's the reason they will be in the attendance list. Okay, should be the setting not updated. Okay, all right. So we just continue first. Let's see what's happened. Okay, so those just because I done the setting, okay, but still have the same issues back. Okay, could be some updated and same those are don't have the chat meeting, don't have the icons. Okay, it means you need to update your team. Okay, you need to sign out. Okay, log out, then sign in back, or you need to restart your laptop. Either one. Okay, so we just try to continue a bit more. Okay. Okay, so just have a look on this part here. Okay. Okay, so based on this induction electrostatic, electrostatic part here, you may have a look. They shows you in terms of a diagram where they put as a A and B. Okay, so unless I was muted, please inform me again in the chat. So you have the A, you have the B. So in terms of not device, but they just shows you in terms of A and B. Okay, based on the charge. All right. So in terms of the A, you can see all the charge that you have surrounded was a positive charge. For the B, all the charge there was surrounded was a positive with a negative. Positive with a negative. Okay, when you have the charge movements happen, okay, between the two A and B, okay, what will happen? They have a bounded charge. So at this part, all the negative electrons will be at one side. You may have a look the negative, okay, ions, and also the positive ion will be in the next part here. Okay, so the one we have in a positive we call as a free charge. The one we have the negative part they call as a bounded charge. But you may have a look the way how they attracted based on the charge here. So it means when your first part here is a A, okay, the device here is A, which is covered up with a positive charge, they will be attracted to negative. That's why you can see all the negative ions surrounded at this point, at this part here. Meanwhile, the positive charge will be surrounded or will be separated from the negative to this free charge at this part. And what will happen? Okay, so when you see when you have a charge movements happen, the positive remain the same, but the positive they shows you they will be grounded. So this icon we use as a ground. Okay, this part we use as a ground. Okay, so once part is grounded and the actual part for your device, I mean the B part here, okay, the charge is removed. It means we don't have any charge at the B anymore because all the negative will be attracted to this part, right, based on the positive charge. So indirectly you're going to move to the A part. So the positive charge which is grounded will be disappear from the positive charge here. Okay, that's the reason we can't have any charge, not can't have, okay, we don't have any charge here. So that's the one you need to know based on the inductions electrostatic. It means the positive will be attracted to the negative, or they separated the negative ion with the positive ion. Meanwhile, the positive automatically will be assumed or will be assigned to the negative. It means they're going to grounded, not negative, they will be grounded. Ground. Okay, so it means ground will be stand for the negative part here. So it will be disappear from your charge here. Same goes to your negative part. Will be attracted to the positive charge here. All right. So this is based on the electrostatic.
Miss, you are muted.
Miss.
Okay, what should I say right now? Miss can't continue with the class with the mute, with the no mute, because when I delivered, you're also not going to understand. Sometimes I'm talk, then go silence. Okay. Yeah, same goes to me. I also can't focus. I also can't concentrate. Okay. Okay. All right. Okay. Since we have some issues, okay, let's see. We try to handle it. Okay. Maybe in the next class, Miss repeat back the one we have in this chapter. Okay. What I need you to do now. Okay. From this slide, I hope it's not mute. Okay, from this slide, okay, what I need you to do, okay, take note before I was mute. Okay, you have a look on your slide, download your slide, get it your slide, the chapter 1 electrical field, just get it, save in your laptop. Please save it in your laptop. Okay, done. You can give me some response in the meeting chat. Are you done? My notebook is blank. Oh, okay. All right. Just do the one Miss asked you. Okay, get the notes, the PDF notes. Okay, done. All right, Tong. How about the others? Just get the slides from you. I'm removed it again. Okay, misunderstand. Okay, just get the slides. Okay, get the slides. Get the slides notes. The PDF. Okay. General. Okay. What Miss asked, you go to your team. Go to your team. Okay. Go to your team. Under electric field. Okay. Go to your file. Not. Sorry. Go to your general. Go to general channel. Click file. Class material. Okay. Choose chapter electric field. Download the chapter 1. The one Miss explained it was chapter 5. Okay, let's finish up. The chapter 1, download the chapter 1, keep with you. Everyone, please download. I need some cooperations with you. Since I have all the good students for this intake, I think will always listen to me. Okay, so please download this chapter 1. Okay, those done, just put a remark for me.
Done, miss. Done, miss.
Done. Okay, all right. Thank you. I hope others please do it. Okay, thanks for the highlighted this part here. Yes. Okay, done. Others, give me response.
Done, miss.
Okay, all right, thank you. Okay, so once you're done, okay, what you need to do, okay, from the slide number 12, just have a look from the slide number 12. Okay, so you need to do some self-study, but don't worry, I will repeat back for the next class. Okay, just have a look on the slide number 12. Okay, from the slide number 12, okay, this part maybe you can leave it first. It's just based on your electrical field. Okay, how is it works based on the charge. I want you to concentrate on the chapter slide number 19. Just have a look on the slide number 19. Slide number 19. Just have a look slide number 19. Later I write in your meeting chat. Slide number 19. Okay, take note, just write down first. Then you go with the slide number 20. All the equations, all the slide with the equation. Slide number 20. Okay, I think you should know these two. Okay, slide 21. Slide 27. Okay, what I need you to do right now, okay, Miss needs some help from you, okay, a favor from you. So from the slide number, the one we stop at slide number 12. Okay, after that, you may stop too based on the theory part. Okay, I want you straight go to slide number 19. Straight away go to slide number 19, slide number 20, slide number 21. Then you skip or you jump to slide number 27. Okay, and 28. I want you to have study first by your own. Study first by your own. Understand the formula. Yes, thank you. Slide number 19, 20, 21. 20. Yes, I want you to study first. I mean, you just go through the based on the equations, based on the formula. Just have a look first. Maybe miss straight on the discussions part, based on the calculations part. Okay, so now we're going to do a Q&A sections. I give you 10 to 15. Okay, maybe I give you 20 minutes. Go through the slides 19, 20, 21, 27, and 28. take note about the equations, take note about the parameters, okay? Anything that they mentioned it in the slide number 19, 20, 21, 27, and 28. After 20 minutes, I'm going to ask you a questions. Just understand the equations. Slide number 19. Based on the second law, Coulomb's law, okay, the specific equations here based on the two molecule or two particles here, okay, where they shows you have the K, you have the Q, you have the R. Just understand the equations first. So from the equations, you will find out they ask you to find based on the force, F. Okay, so force between two molecule. And where they stated the K as a constant value, they have no changes on the K value. Okay, and where they point out for you the Q, which stands for the charge as usual. And these equations, you may have a look, they have written for you Q1 and Q2. So indirectly, you must have two molecules with you. I mean, two molecules based on your calculations later on, okay? And the R represent as a distance between two charges, okay? And the unit, they always take note, is based on the in meter, okay? The units in the meter. At the same time, they also defined it for you based on the permittivity of the medium. How they get the equations of the K. And where the K equal to 1, divide by 4 pi permittivity. It's like a E Italy. The symbols like a E Italy. Okay, and where this shows you equal based on the permittivity R with the permittivity like a sounds like a permittivity O. But they have a difference between the R with the O. R stand for the permittivity of the mediums here. A relative permittivity, the overall we stand as a permittivity of the medium. But from there, they divided to two. One is relative, one is absolute. Okay, at the same time, they highlighted to you the permittivity. Relative is stand for 1 because it's hair. Okay, because of the free space. Alright, at the same time, they highlighted to you based on the slide number 19. Absolute permittivity is 8.854. The equations here. Okay, write down. I want you to write down in your book, in your notebook, the equation. Okay, and write down at the side. Okay, if it's a constant value, write. Okay, K is stand for constant value. Write in your notes. Okay, so the R stand for what? Stand for distance. Okay, right at the side. R stand for the distance. Okay, and jot down based on your permittivity. So when they have the E, sounds like Italy E. Okay, that is stand for permittivity of the medium. It means it's based on the material. This one, permittivity of the medium. This one. Okay. Write down in your notes. Write down in your notes. Okay, try to understand. Okay, so once you've done that, just jot down the equations. Okay, so have a look on they wrote as a Q1 with the Q2. This one. Just at the Q1 with the Q2. So based on the Q1 and Q2, between these two, okay, they wrote as a R. So that's the one, the distance between the two charts here. Can I snapshot the page and paste it in a OneNote? Oh, can. You want me to do that in a OneNote? Okay.
No, you asked me to jot it down, so I just did that. So I just.
Oh, okay. All right. Just take note based on the equations here. Okay, so this is the one, slide number 19. Okay, all right. So jot down. Once you're done, you can go on with the next slide. Slide number 20. This means this one. Okay, permittivity. Okay, substance of the stored electrical energy in electrical field. So they have a formula that we need to use to calculate. Okay, at this point, they just let you know based on the electric field. Okay, how they calculate based on the equation. So this is the one we call as electric field strength, which is a capital letter of the E. Yeah? Maintain, have the electric flux and produce a particular value of electric flux density, which we call as a D. So take note, the D stands for electric flux density. Okay, meanwhile, the E stands for electric field strength. Okay, at this point, you will know what is it stand for. This is stand for the permittivity. This one, permittivity. So write down in your book based on the equations here. Okay, once you're done, go on with the next slide. Slide 21. Okay. Based on this slide, they shows you based on the permittivity of the medium. Okay, we call as a material. Okay, it means this one. As just now, Miss specific based on the E Italy. Okay, this one I call as E Italy. Okay, so this is the one we call as a permittivity. Make sure you call as a permittivity. Okay, permittivity of the medium. This symbol. Okay, how to get this equation? How to get this value? Should be equal to permittivity relative, permittivity absolute. Okay, it means this one with this one. Okay, take note about that. Okay, so we call permittivity of the medium is this one. This one we call as a relative. This one we call as absolute. Okay, and then if you realize at this point the absolute value will be constant, this value. Take note, this is the value constant. You cannot change the value, you must maintain this value. But some of the reference books, they also using 8 is the same value, okay, but this specific 8.85 times with 10 power of minus 12. Okay, this one is a unit. Okay, F over M meter is a unit. Okay, so this one, take note, either you use 8.854 or you can use 8.85. Some reference books, they have 8.85. Okay, some they go, the more accurate points that you have, it means the more points that you have after the point, it means it's more accurate. Okay, okay, all right. At this last point here, the point number 3, just have a look on this part, vacuum, which they call as a relative equal to 1. Okay, and take note one more part, relative permittivity, always they will specific when they give you a questions. Okay, what type of the material that you're using. Okay, either you're using copper, either you're using aluminium, okay, either you're using mica, what type of the material. So from the material, you need to specific what's the value that you need to substitute in. Okay, so far right now, you just understand the equations, how is it works. And write down in your notes. I want you to write down in your notes. Yes, it looks easy, but later once you want to calculate, substitute your value, then you feel a bit difficult to find the formula. So write down the formula. Hope not mute. Okay. So once done, go on with the next chapter. Okay, based on electric flux density. Write down the formula. I want you to write down the formula. Okay, is the electric flux density? Okay, a unit flux, okay, is defined as emanating from a positive charge. Okay, as usual, they take note based on the one column, this means 1C. Therefore, they also have an electric flux. Okay, these are the symbols. Okay, the symbols is like this form, electrical flux. Okay, it's measured in column. It means measured in a unit of the charge. All right, have a look on the third point. They also specific based on the flux density, the amount of the flux passing through a identified area of the A. It means identified area. It means is based on the area materials, the materials. Okay. Okay, in perpendicular to the directions of the flux. Okay, so take note on this part. This is the charge. Okay, and the next one is area. So that's why we have this equation. The up one is charge. The unit we measure is this one. Okay, based on the C. Okay, that's why they wrote the answer, the equations C. The next one, divide by the area. Okay, so divide area means related to the material. What type of the material that are you using? Okay, so the A. So this A they measure based on the meter, the unit in the meter, not cm. Is not cm. This is charge. This is meter. Okay, and how to get, okay, why we doing charge divide by the area? Because to get the D. So this D, the one reflected as a flux density, okay, electrical flux density. Have a look back on the title. Electric flux density, which is 10 for the D, which is 10 for the D. Okay, just right now, just go back up, just go back up. Okay, have a look on this slide, the slide number 20. Where you have the electric flux density divided by the electric field strength to get the permittivity. Okay. This one you calculate to define the electrical flux density. Okay. charged with the area. So it means, okay, example, your area is a square meter, sorry, a square, okay, rectangular shape. Okay, so you need to know the area. How much is it? Then only.
Is you're lagging a second ago.
Okay, I miss repeat back. Okay, I repeat back. Electrical flux density equal to the Q divided by the A. So A represent the area. Okay, not necessarily they're going to give you a rectangular. They can give you a circle, but it depends what kind of the shape. Usually they always say square type. When it's come to the cable copper, so usually our cable or the wire always stand in the circle, right? Okay, sometimes you need to calculate based on this part too. But this time you just take note based on the area. It means you need to calculate the area. Okay, let's go for the next part. I want you to jot down the formula because later I'm going to ask Q&A section. Okay, and the next one, just have a look on the next one. Is based on electric flux density. Let's go back here. Okay, at this point, E, to get the permittivity, I need to substitute the electric field strength. So how to get the formulas of the E? So that's the time I need to refer back to this equation. Let's have a look on these equations, how we get the answer here. Okay, let's have a look on this one. They define based on the density, flux density. Then they're using an electric flux. So this is electric flux, all right, divide by the area. Take note. The next one, they shows you in terms of flux density, which is equal to your permittivity times with the electric field here. Okay, intensive. They also call as a strength, the same. So jot down this equation, jot down this equation. You will understand the equations when you start to do a calculations. Then you need to find the key point. Okay, this value or parameter stand for what? Is it stand for flux density? Is it stand for electrical strength? So that's the thing. So jot down your formula. Okay. All right. So that's the one that you need to jot down and try to understand. Take your time, try to understand. Slide 24. Okay. This one I will explain. You don't need to do anything. But I want you to understand the slide numbers that I wrote in the meeting. The one your friends wrote in the meeting chat. 19, 20, 21, 27, and 28. Try to understand. Those done, you just put a remark or just let me know in the meeting chat. You may write your answers here. Because I'm going to ask the Q&A sections in a while. Those done the self-study by your own based on the equations, write your just let me know. Okay, you're done? Any response? Okay. Ryan, give me the feedback. How about others? Just make a self-study based on the equations. Only 5 slides. Okay, all right. Ryan, Tong, done. How about others? I'm done. Okay, all right. Critical. Okay. All right. Those done, be ready. Later on, I will call one of you to answer my questions based on the equations. Okay. All right. Okay. All right. Okay. Okay. Okay, Tangkai. Some of you still not yet. Okay. Muhammad. Hmm. Okay, Lin Jin. All right. All right, Muhammad done. All right. Okay, so before we start with the Q&A section, I think one of you, wait. Okay, so before we start with the Q&A sections, I just want to give you one explanations. Okay, you may have a look on the slide, this slide. Okay, Miss can't remember which slide number. Okay, slide number 24. Okay, so in the slide 24, they just let you have a look on the pink box here. You have the pink box here. So in the pink box here, actually they defined it based on the permittivity. So permittivity based on the material. So example, they write hair, they write glass, they write mica, even they write a mineral oil. Okay, even they write as a paper. Even you have the PVC. Okay, each of the one they listed here as a material, they have the permittivity. So this permittivity is based on a relative permittivity. Example, air equals to 1. Even though they highlighted 1.0006, we always assume or we always take the answers as a 1. Okay, that's why when you have a look on this part, they said freeze phase or they said hair or they said vacuum, they always take note 1. Okay, even though they write as 1.006, they just point out as a 1. Okay, example, when you take as a glass, okay, the primitive relative, they were specific for you because this glass, okay, in terms of here, they shows in terms of the range 5 to 12. So when you have the questions, example, when we do a calculation, they will specific for you, the glass is how much. Okay, example, we did for the mica. So mica, the things, they is between the range 4 to 8. So they will specific for you, okay, yeah, mica, the primitive relative is a 5 or 6. They will specific for you. So this table is just an example for you based on the primitivity, based on the materials, okay, relative primitivity, okay. So let's go on with some Q&A sections. Hmm. You want to, oh, okay. Not much equations, all right. Okay, I hope everyone can listen to me. Okay, those, I'm going to write your name here. Okay, so those, the person that I'm write your name here. So I will ask you questions and you feedback to me. Either you open your mic or you give your answer in the meeting chat. Okay, but I want the one Miss ask, the persons only responded to me. The others, you keep quiet. Okay, when I ask you, then you answer me. All right. So I go on with the from the list here. Okay, I go on with the first person here, the list, huh? SL. Okay. Are you there? Can you hear me?
Yes, Miss.
Okay, all right. Okay. So my questions, how you calculate the flux density?
Flux density.
Electric flux density. You can write based on the equation. You can explain what you can explain.
Charge divided by the area.
Charge divided by the
Area.
area. So that stands for density, flux density.
Electric flux density.
Okay, so let's see. Okay, thank you for your answer. So let's see. So Miss asked for flux density. So the answer that he given to me is where based on the chart. Oh, is based on the electric flux divided by the area. Okay, or also we have the charge divided by the area. So two, if we give me two answer, both answer also I will accept it because one is charge divided by the area, one is based on the electric flux divided by the area. So they have a two equation. Just take note. Just take note. Okay, the next person. Are you there?
Yes, Miss.
Okay. So how you describe or what the definitions of a primitivity? How you explain? How you defined?
It is the ability of a substance
Hmm?
to store electrical energy in an electric field.
Okay, so how we calculate it? Usually how we calculate?
It is
Then
electric. It is a electric flux density over electric.
Okay. All right. So thanks for the answer, Benny. Okay, the one Miss asked actually based on the primitivity is uh based on the equation. You can describe based on the equations. Okay, where is it primitivity? So how we describe the primitivity? Hmm. Okay, one you can may have some explanations based on the permittivity, but the one Miss asked, the one I want you to answer is based on this one, based on the equations, how you get the permittivity, how you define the permittivity. So when anyone said permittivity is referred to your medium. So when they said medium is where you need to have relative, you need to have absolute, permittive, absolute, then only you can calculate. Same time, other answers also we can accept if the definitions of the permittivity, then you can let me know the definition, what is it stand for. Okay, next one. Okay. Ilham, okay. Are you there?
Yes, miss.
Okay, so now let me know from the equation, the 5 slide. Okay, define for me one equations.
Any equations?
Any equations from the 5 slides that you have go through. We have slides here. From these slides, any equation in there you can define it.
Like what should I define?
Any equations based on the formula. Okay, how you define electrical field strength?
Electrical field.
Miss can't hear you. Someone off him? Off
Miss,
his mic?
someone is keep muting me.
Okay. All right. So it's okay. Never mind. Okay. So now I think I'm not going to call one by one. Maybe randomly those can open your mic. You just let me know. Okay. The next questions. Okay. Can anyone point out for me the second law based on the second law columns?
Are you talking about the force between two particles, miss?
Yes. What is it? Can you describe for me the equations or what you understand based on the equations?
Okay, so the force is equivalent to the constant.
Oh, someone off him. Someone mute him.
Okay, maybe I'll type it in the chat, miss.
Okay. Why we have these issues? We 15 of us. Okay, while waiting for your friends to give me the answer. Okay, Benny, mistake note. Okay, while waiting for your friends, one of your friends answer, Miss want to give you the next question. Okay, what's the constant value of the K? Can anyone specify for me? You may write in your meeting chat. What the constant value of the K?
The constant value of K is the proportionality.
How much? The value. The K value is how much?
It's 9.0 times
Yes.
10 to the power 9.
Yes, okay, all right. Okay, the next one. Okay, before that, let me read the answers given by your friend. Okay, two force between two particles is calculated by using the constants of Yep. Multiples is by change of the each particular divided by the square of the distance between the particular. All right, thanks for your answer. Okay, let's go with the next one. Okay, for the next one, based on the permittivity equations, we have one constant value. What is the constant value? What's the name they defined it for the permittivity, which is we stated as a constant, and what the value will be? Anyone? Maybe you can write in the meeting chat. Yes. All right. The value? May I know the value? How much the value? Oh, yes. Brian, just take note, it's 8,000. You should have 8 point. Yep, Lim Wei. Yes, that's the right answer. Okay, so let's go with the next one. Okay, in case you just define for me the equations. Okay, unless we want to have, I want to calculate based on the electric field strength. What the equation that I need to have? Write the equations. You may write the equations. Miss, repeat back the equations for for the field strength, electrical field strength. Yep. Okay, all right. So let's go with the next one here. Okay, if we have charge, example, we have the charge. So is it the charge can be defined as positive charge with the negative charge? Or when you calculate, okay, when you calculate based on the charge, do we need to take it based on the positive charge with the negative charge? Okay, example this one. Okay, Miss, go on with your slides here. Just have a look on your slides here. Okay, this one. Okay, example this one, they given to you two particulars based on the charge. So they have highlighted.
Miss, you're muted.
Okay, so what Miss asked just now, when you have two particular charge, okay, positive Q equals to A, when you have negative Q equal to the B.
Miss, you're muted again.
Okay, my question, when you do a calculation based on this formula, do polarity of the positive and negative of the charge need to take note?
No.
No. Okay, when we have the polarity of the charge, positive and negative, is it defined the directions of the movements of the charge?
Yes.
Yes, okay. Thank you for your answer. Okay. Okay, Miss don't want to drag more time on this part here. Okay, let's go with some I'm not sure whether I able to show you the demo or not. Okay, but let's see. Okay, what I need you to do right now, okay, I want you to go to your OneNote. Under OneNote, okay, not this one. Okay, not this one. Okay, we have few tutorials calculations. Okay, one is planned to do together with you all. Okay, one I will leave it to you the task, but I think you can't complete it by today due to some technical issue.
Miss, you're muted.
Okay, for the tutorial sections, okay, I mean, go on with the tutorial part here directly. Okay, I don't want to waste any time here. So we go on with the simple, then we go on with the not complicated, like mediums level. Okay, so the first one, have a look on your OneNote. Okay, what I need you to do, write in the piece of paper. Once you're done, you send in the meeting chat, or you pasted your answer in the OneNote. Those having issues with the OneNote, it's okay. You write in a piece of paper, screenshot, and send in the meeting chat. Can you do it now? Based on the simple task, this one. Okay, forget about your OneNote. If those having issues, you just write in a piece of paper, screenshot, send in the meeting chat. Don't discuss with your friend. Come out with your answer, your own answer. But you can refer to your slides. You can have a look on your slides. The one Miss wrote here as A, the one I wrote here as A, B, and C. So example, the A is 10 power of 12. The one, this shape is a power, related to the power. Okay, power 12, power minus 6, power 9. Number 2 is related to this one, A, B, and C. Number 1, draw a simple circuit diagram, more than 3 elements. So elements means it's a component. Oh, you can draw in your OneNote under your folder. What is it? You may draw in your folder. It means, example, who's the person?
Oops, sorry, miss.
Okay.
I didn't realize this is a shared file. I thought this was my.
Oh, okay, okay. Those can do with a OneNote. You can continue with the OneNote. Those can't have issues with a OneNote. It's okay. You write in a piece of paper. You draw in a piece of paper. Screenshot, then send in the meeting chat. After that, we take a break. Once we completed this part, we take a break.
Miss, under the section draw where?
You ask this one, is it? Or your folder?
My
Okay, your folder, click on the book. So your folders will be here. Okay, example Excel here. So you can do it under homework. The subfolder, you can do it under homework.
okay, Miss.
Okay. Okay, I give you 10 minutes. Then we take a break. Then we continue back. The first task will be simple always. Someone doing it on the my file in my file, I think so. Okay, I get one response.
Hi, Miss, I'm done. I put it as homework.
Okay, all right. I will check in a while. Okay, this one of your friends did. Tera, micro, giga, centi, isa, mega, milli, pico, kili. Oh, okay. All right. Okay, so just for number one, so if you see number one, Miss highlighted to you, draw a simple circuit diagram. Okay, it means circuit diagram, but I highlighted to you more than 3 elements. Okay, usually you can stand with the 4 elements. It's better to have 4 elements. So it means 4 components. So from the one that Miss can see here, 1, 2, 3. Okay, maybe this one is counted as a source, battery. This is your light. This is a resistor. So it means it's 3. The one means ours is more than 3 elements. It means more than 3 components. Okay. Anyway, thanks for the answer. Okay, I'll go very fast. The next one is Lim Jane. Why is name too long? Let's see. Is it Lim Jin Yan? Oh, Lim. Okay. Same to the Lim here. Okay, I have battery. Okay, 1, 2, 3. A is stand for what? Oh, you assume as a multimeter, is it? Okay, this is we're not going to call as an element. This is just the symbols of an ammeter. Okay, as a symbols of a multimeter, the measurements value. So this one is can't count as a component or elements. Okay, so basically I can say you have the battery, you have the switch, you have the light, the lamp here. So it's 3. Okay, it's better for you to add a resistor. Okay, then it's be completed. You have 4 elements. Resistor means the one just now I showed you a resistor. Okay, tera, micro, giga, centi. Okay, all right, mega, milli, pico, and kilo. So remember, take note your scientific value. Please remember, it's very important. Even though once you completed your EEP module, when you go for different module, this is where we take note based on your the way you write your value in measurements value. Okay, thank you, Lim. So let's go with Tong Ching. Tong Ching. Okay, you have the light. This is 3-cell battery. He have the switch. He have the resistor. Okay, I accept this answer. I accept this answer. Okay, I think others should be right. Tera, micro, giga. Oh, symbol. Okay, TMG. All right. Centi is omega. CEM. Okay. Milli, pico, kilo. All right. Thanks for the answer. Let's go with the next person here. Hope not mute. Lim. Lim, Tera. Okay. Where's your diagram? Can I see your diagram? Oh, you submitted earlier. No. I want to see the diagram. A circuit diagram. Lim Wei. It's long moon. Okay, switch, wire. Okay. Wire means can't count it as elements. Okay. Wire we need to have, okay, like interconnections between the elements or between the components. Okay. So this also means count as 1, 2, 3. Okay. It's not the wrong answer, it's the right answer, but the one misstated, I want more than 3 elements. Okay. Not necessary you always need to have a light. You can put other electronic components. Okay, we have capacitor, we have inductor. Okay. Tera, micro, giga, centi. Okay. Isa, E, mega, milli. Okay, all right. Quite smaller. Kilo. Okay. All right. Let's go with the next answer here. Oh, took some time to load. Okay. Okay. Muhammad. A resistance lamp battery is 3. Okay, the others I think should be no problem based on the scientific value. Okay, where's the unit? The symbol. If a centi means you need to know what the symbol. If mega means you need to know what is the symbol. Milli means, okay, remember mega with the milli, they have a difference. Mega, they always shows the capital letter of the M. If milli means the always small letter of M. Okay. Sometimes that's also you can have a loose marks based on your milli and mega. That means I done. You can check in on okay. All right, in a OneNote homework. Tankai, okay. Tankai. All right, resistance. Okay, 4 element. All right, I accepted the answer. Okay. Tera. All right. T micro giga CEM milli pico kilo. Yes. Okay, thanks for the answer. Okay. Wait. Oh, he add a resistance. All right. Okay, this is something new I saw. Okay, I mean, this is a resistor, represent a resistor, but he used a variable resistance. Okay, and he used an alternative source here based on the cell. He has the switch, he has the diode. Okay, but this diode connections is a different way. Okay. Positive should be the diode in the forward bias, but it's okay. That's for drawing purpose. This is a symbols of it for you to measure the ammeter. Okay, so this we won't will not counted as a component or element, but the symbol to measure the value of an ammeter, okay, the current flow. All right. Okay, that's the answer. All right, I take note about your answer. So the others, I go with the one note. Thanks for your answer. Okay, this one. Okay, maybe those I can't see the answers in the one note. Maybe he sent in a meeting chat. I think same goes here. All right. Oh, okay. Fatin answer, yeah. Okay. Lamp, is it okay? Resistant, okay. Battery. Switch. Ammeter. Okay, this is a symbols of ammeter. So 1, 2, 3, 4. Okay. Tera, micro, giga, centi, CN. Okay, never mind. This typo error. Okay, mega, milli, pico. Okay, all right. Thanks for the answer, Fatin. One. So you did in class test? Class notes. Oh, you copy. Oh, you print out. Okay, you keep the notes in the class notes. All right. Homework. We paste it down here. Okay. Maybe it's sent in the meeting chat. Okay, let me check later. Okay, it's sent in the meeting chat. Lim Wei. I think Lim Wei also chat in the meeting chat. Long quizzes. Ultimate quizzes. Okay. All right. Okay, so we have class note. Oh, pasted answers. The chapters here. Good. Okay, so let's go with the next person. Oh, okay. Light, variable, resistant, resistor, battery, switch. All right. Answer number 2. Tera, micro, giga, centi. Okay, is E, mega.
Maybe that was a fuse.
Fuse. Which? Oh, this one. Okay. All right. Okay. So I just want to specific for you when you have a resistor. Just take note. Extra information. Okay, this one we just have a symbol, but usually when you want to sketch, draw, okay, the resistance symbols we use this one. Okay, if variable resistance will be this one. These are the symbols of the resistor. Okay, but in terms in the slide just now we have this one. Okay, I will accept it. But when it's come the symbols of resistor, you must use this one. Take note that you must use this one, this resistor. Okay, just want to point out this part here. Okay, I think Tanka also sent just now in the meeting chat. Okay, I think Tong also sent in the meeting chat. Okay, all right. So thanks for your answer. So let's go with the next part. But before we go, Kwang, I did in a one note. Okay, but Miss can't find your answer. Oh, Miss can't find your answer. Okay, never mind. Okay, so we just take a break for a while before we continue for the next part here. Okay, so then after that, I will leave it to you as an offline tutorial you need to do. Then make sure you're done. The next week we'll discuss. Okay, so we just take a break for a while. Is it okay? We take a break for a while.
Yes, miss.
Okay,
Okay,
miss.
so we take
Okay,
a bit long break. Is it okay? 20 minutes, is it okay? Or 15 minutes?
Okay, miss.
Okay. How about others? Give me some response. 15 minutes or 20 minutes? Okay. How about others? 15 minutes.
Is enough.
Oh, Okay, how about the others? 10 minutes, 15 minutes, okay.
15 minutes is okay.
Okay, I think, all right, we go with the majority, maybe 15 minutes. I would like to end the class as soon as possible. Why?
Like I would like to study all at once, then finish. Then I can.
All right, so even Miss also want to finish the class earlier, but due to some technical issues, I could not explain. Then the next slot actually should be the offline. So just after 15 minutes, you just keep hold, be patient with me. Then we finish up. We try to settle one questions. Then after that, I Miss will leave it to you, the tutorial. Okay. So for currently, we take 15 minutes a break. Okay, so is it everyone is there? So everyone is there? Can I get some response?
Yes, Miss. I'm here.
Okay.
I'm here.
Okay. How about the others? Still have 2 minutes to be 15 minutes. Okay, do everyone is here? Can I start? Just few minutes some more, then after that we can end the class. Okay. All right. I hope everyone is here right now, huh? Okay, Tangkai, are you there? Longmoon, are you there?
Yes, Miss.
Okay. Tangkai, are you there? Okay. I think they have no response from Tangkai.
Yes, Miss, I'm here.
Okay, all right. So don't worry, some more few minutes I will take your time. After that, we go with the offline class. Okay. So just have a look on your OneNote. You may have a look on your OneNote. Okay.
Miss, you're muted.
Okay, so everyone go to your OneNote. I won't going to take a long time for this part here. I just a few, maybe 10 minutes to 15 minutes for me to explain. After that, we go on with a offline class. Okay, so make sure you done your task. Okay, at least by next week Friday, before the Friday, so it'll be easy for us to discuss back based on the calculations part. Okay, so now you have a look on a OneNote. Okay, this is the one we did just now, the simple one. Okay, so I have one more part. Okay, one more calculations, but these calculations from your notes. Okay, from your slide, the one Miss teach you just now, the one I taught you just now, based on the charts, right? Okay, so this will be in this part. Slide notes, you may have a look, chapter slide notes. Okay,
Miss, you're muted.
okay. In a OneNote, okay, in the slide notes, okay, the first one I will give you a
Miss, you're muted again.
okay. All right, so the first one I'm going to explain to you. The others you're going to do as offline. Miss, repeat back from your OneNote, the slides one. Okay, the first one, the first question I'm going to show you as an example. Okay, the others notes. Okay, I mean the others questions. Okay, question number 2, the others one that you're going to do by your own. Okay, take note, you're going to do by your own and make sure you complete it before Friday, next week Friday, so easy for us to discuss for next week class. Okay, so just take note about this one. At the same time, okay, the first one is demo. Okay, and you can find one more part here based on okay, basic This is based on the principal electrical quantities. Okay, this is one more task. Okay, Miss not sure whether you're able to do that or not, but I want you to try first. Okay, try first to do this one. So you have two tasks. Okay, one is the slide notes. It means the one we have in from your notes, from your slides. The second one is based from electrical quantity. Okay, this is not from your notes. This is not from your notes. Okay, but I want you try to do these questions. Okay, we will discuss for the next class. All right. Okay, the first example I will show to you. After that, we go on with the offline class. Okay. So the first one, just have a look on the first one. Okay, the first one. Okay, they can give you a long question. They can give you a short question. So the important for us, okay, is where we're going to have a questions on the models. No, it's not from the models. This is from the tutorial section. This from the slides. Okay, the one I shows you, that one is from the not from a tutorial question. That is from a book, reference book questions. Okay, so let's go on with this one. Calculate the distance. Okay, they can give you a long question. They can give you a short question. Okay, most of the important things you highlighted the key point that you need to understand. Okay, so first one. Okay, based on the first question here from your slides, this from your slides. Okay, calculate the distance of the separations between two electrons. So from here, you need to know the one they ask you, okay, the one that you need to define or determine is distance. Okay, besides that, take note the word calculator, the word calculate, sometimes they also can use the word determine. So unless they're using the word determine, it means you're not going to explain, but you need to calculate. Take note, Miss, just let you know, calculate means, of course, you already know, you need to do some calculations. Okay, sometimes they're using the word, this word, determine. Okay, so determine not necessary for you to explain things. Okay, sometimes the word determine, they use to calculate. Okay, you need to calculate. All right, so just go back to your questions here. Calculate the distance of the separations between two electrons. So from here, you need to identify the things they highlighted to you is distance. Okay, so distance means is R. Take note, is R. Okay, and where you have the separations between two electrons, it means two molecule. Okay, you have two electrons in vacuum. It means free space. All right, this is the one free space for which the electrical force between them is equal. Okay, they give you one more clue. Take note, one more hidden they given to you, which is electric force between them is equal. Take note the word they mentioned it is equal to the gravity a force of one electron of the earth on the earth. So it means your force for your electric with the gravity force are the same because they're using the word equal. Once you take note about this part equal, and they also give you one more hidden, which is okay, not hidden as a clue. Okay, they already let you know the mass of the electron, okay, is equal to 9.1 times with 10 power minus 31 kilogram. Okay, take note, this is the mass of the electron. They give you the measurements in kilogram. Okay, and the next one, charged electron. So this the one, the value of the charge, okay, which is a 1.6. Okay, the specific value they given to you is 1.6 times 10 power minus 19 C. Okay, so from here you need to know, okay, even they already shows you the answer, the last answer, you must get this one. Okay, so let's the first one is give you some example, some idea how to get the answers here. So the first thing, I'm going to write the key point they given to me, so easy for me to specific to go on with the calculations. Okay, so the mass electron, okay, which is 9.10 power of 31 kilogram. Take note, the unit was kilogram. Okay, and the same time the charged electron, C is charged electron, okay, which is 1.6 times 10 minus 19 C. The unit is C. Okay, and from here, once I read the questions, I need to know when they try to get the answer. They ask for the distance. It means the equation, the right equation that I need to be used. So the right equation that I need to be implement, or the thing that I need to apply, okay, is force equal to K times with Q1 okay, times with the Q2 based on the second law, okay, and divide by R power of 2. So these are the equations. Once I read the question, I need to know which equation that I need to use. So from here, we go on with these equations. Once I get the equations, I need to justify some things here. The most important things, I need to convert into a Newton, a kilogram into a Newton. And at the same time, they already let me know, okay, they already we can get to know that is equal. The force for electrical and gravity are equal. Okay, so what I need to do, okay, I think most of you know about this one. Okay, once you convert milligram or kilogram, okay, you need to convert to the Newton. So example, 1 milligram, when you convert to Newton, Miss can't remember, but should be 0.00000098. Okay, later on, please check. Okay, you may check later on when you convert to your milligram. Okay, so Miss can remember for 1 kilogram. So 1 kilogram, when you convert it to Newton, you need to know it will be 9.8166. Okay, and they have a numbers also, but just I take note the earliest numbers here, 9.8166, which is Newton. Okay, I just simplify, okay, similar answers which are going to stand as a 9.81 Newton. Okay, so take note your kilogram converted to Newton. Okay, so once you done that, okay, and besides that, I just want to give you some examples. So example, you have, okay, a box. Okay, so this box carry for 1 kilogram. Okay, so you need to calculate based on the force, right? Okay, so the equation we have m, okay, force equal to ma. So one things we take note based on this equation. Now, okay, we don't have this equation in the slide, but this is a basic equation that you need to know. Okay, it's related to the force calculations. Okay, so from here we can identify the force for this one, how to get the answer for this one. Okay, the mass calculated based on the Newton that you given to you based on the atom. Okay, so once you understand this basic equation, you can continue with calculate for the next part. So in the next part, okay, gravitational force. Okay, so I already know is equal, okay, equal to the electrical force. Okay, so force equal to 9.1. This means this one, the earliest one. Okay, in kilogram. Okay, I need to convert in a Newton. So this is the one, 1.9 times with 10 power of 31 times with 9.81 Newton. Take note, I need to convert the kilogram into a Newton because we always measure the force in a Newton. Okay, so once I done the calculations, I need to know how much the value for this part, the force here. Okay, now I substitute the one that I have here. It means these are the real equations, the original equations. Okay, from the force here, I'm going to substitute into this equation, these equations. Okay, so just have a look. I write back the equations here. Force equal to the K, Q1 with the Q2 with the R2. Okay, so the way I'm going to specify, or the way I'm going to substitute the value, I'm going to take this one, 9.1 times with 10, okay, minus 31 times with this one, 9.81. Okay, Newton, which is equal to the K. So I need to know the value of the K is what. Okay, I want someone give me the answers of the K constant value. Anyone volunteer?
It's 0. Yeah, let me check. I know it's
The K value, the K value. This should be constant value. Anyone?
9.0 times 10 to the power of 9.
Yes, exactly. This is the answer, the constant value. So you need to remember the K value. Remember the constant value you need to remember. You must remember. Okay. So this is 9. It's not A, it's a 9. Once I get the K, I proceed with the next one. So the next one is defined the charge. It means Q1 with the Q2. So just go back to my questions. Okay, let's go back to the questions here. So from the questions, I can get to know, okay, it means they said calculate the distance for the separation of two electrons. So they already highlighted to me is the electrons. They not say to me proton or electron. They just specific for me two electrons. Okay, so it means the electrons they're going to have here is the same. Okay, they don't have any difference. They not highlighted to me two electrons with a difference value. Okay, so from here I need to know my Q1 and the Q2, the value of the charge are the same. Okay, is the same. Miss, I do not do something. I do not understand what did you just explain. Okay, just give me 1 minute. Let me explain first, then I explain back. Okay, so on this one, once we have the K, so we have the Q1 with the Q2, right? The charge is the same value because they defined it is 1.6. So in this part, I'm not going to write Q1 and Q2. I just put 1.6 times 10, okay, minus 19 square root. I'm going to use power 2, okay, because the charge is the same. They already specific for us the charge of electron is this the value, okay, and even they let me know 2 electrons, so it means the same thing. All right. Okay. So once you're done, then you can proceed with the next part here, which is R. Okay, so this is R2. So this is a normal maths. How are you going to do your maths? As usual, how you calculate your maths. So bring the R2 here, or you're going to bring out this one here. It's based on your maths calculation. So example, I did step by step. Okay, example means bring this R power of 2 to this side. So when I bring this one this side, of course, I need to know it's a multiple, right? So it means it's going to stand as a multiple. Okay, someone calculate, you may calculate 31, okay, times with 9.81 Newton, okay, with the R2, it means this one, R power of 2, okay, which we get this one. Okay. I'm going to write at the up here. Okay, I think someone is removed. Okay, those are removed, please join back. Okay, I'm going to write the same thing, repeat back here. Just have a look. Okay, 9.1. 9.1 times 10 power of minus 31. Okay, times with this one, 9.81 Newton. Okay, with the R power of 2, okay, which is equal to this one, the K value, okay, which is 9 times 10 power of 9. Continue with the charge value, okay, which is 1.6 power of 19. Okay, so once I done, I can do my as usual. I calculated. Okay, you can bring out everything to here, so it means R power of 2. Usually when you okay, can anyone calculate for me 9 times 10 power of 9 times with 1.6 times power of minus 19? Can you know how much the value? Okay, or give me the direct answer.
Miss, you forgot the square. 1.6 times 10 to the power of negative 19 square. Because got Q1, Q2.
Oh yes, okay. So can anyone, thank you. Can anyone let me know the answer, the last answer once we times this one? Okay, example 1.6. power of 19, okay, then divide by this one, 9.110 power of minus 31, okay, times with 931 Newton. Okay, can anyone let me know, once you settle, once you solve this issue, solve these calculations, how much you get? This one, just this part. 9 times 10 power of 9 times with 1.6 times power of 19. This is not A, is minus negative 19. Okay, divide by 9.1 times 10 minus 31 times with 9.81 Newton. Actually, you can settle here also, no problem. Can I get the last answer? Without this one.
I got 25.81.
Okay, 25.81.
81.
Okay, anyone get the same answer? Anyone get a different answer? Okay, let's see. Do anyone get the answer? 25. Okay. 23. Minus 20. Okay, check back, Linwei. Why is it power minus power 28 here? Okay.
Yes, ma'am, I removed again. Someone is removing me.
Okay. Now, Muhammad, you just join. If anyone remove you, you just join back. Okay, I'll repeat back the example again. 25.809. Okay, this is a more accurate answer given to me. Okay. 29.809. Okay. 25.81 also I accepted. Okay, all right. So let's go with the answers that we have. Okay, example, we took 25.81. Okay, some of you also give me 85.809. Okay, this answer also I accepted because when we rounded, of course, it's 81. Okay, so once you done that, as usual, how you do your math square root? Okay, 25.81. Okay, or square root with this one, 25.809. So you will get the last answer. So your last answer, the one we have in your slides here. But not necessarily every time when you have the answer in the slide will be the right answer. Take note. Okay, so the answer they provided for us. Yes.
What's the point of finding the mg?
What the?
The mg, you know, the 1 mg equals 0.000.
Oh, this one is a Miss just wrote as a equations. Okay, we have 1 mg when we converted. I just asked you to check whether we get 0.00098 Newton or not.
Because I don't see, we didn't use it in like the calculation.
We don't have mg. It's not don't have in a calculation. I just let you know when we have mg, when we converted to Newton, what's the answer that we get.
Okay.
If when we have 1 kilogram and we converted in the Newton, what is it we get? So that's the thing, because we have milligram, we have a kilogram, but in your question they only highlighted for you kilogram. Okay, where we stop. Okay, so just have a look on the answers here. They wrote for you is 5.08 milli. Okay, so when we calculated, okay, when we square root this one, because they asked for distance, okay, of course, power 2, bring up to the next part here, of course, square root. Everyone know here. Okay, so once you're done, it means what you get the answer? 5.08. You should get the answers here. This one. Anyone get different answer? Anyone get different answer? Okay. All right. Everyone keep silent here. Okay. So this is the one example that me shows you based on your questions. Okay. This also me can say is a not very hard question, but it's quite simple question. So I just want to repeat back. Okay. Just give me 5 minutes. Okay. So this, take note, the first one, they ask you to calculate the distance. Okay. So when they ask to calculate the distance, you need to know which equation, the right equation that you need to substitute to get your answer. So based on this part, based on the question, they already let you know they have 2 electrons. So 2 electrons, they already specific for you the value of the 2 electrons. It means the charge of the electron is 1.6. At the same time, they just also let you know the electric force and also the gravitativity force is how much. Okay, where they're using the word equal. So this is one of the clue they given to you. At the same time, they also let you know based on the mass. It means the mass of the electron is 9.1 times with 10 power of minus 31 kilogram. Okay, remember when we come with the concept of the force, okay, usually we have this equation. I hope everyone remember these equations. We have this equation On the slide we don't have, okay, but this always you learn before. I think you learn in your secondary school, not mistaken, miss. So we're using this type of equation, force equal to the mass. Okay, mass calculate with your speed, accelerations based on the speed. Can be 1 meter per second. It depends. Okay, so when we have this one, that's the reason we're using this technique. Not the technique. We need to convert. Okay, is where we need to take note 1 kilogram. When we converted to newtons, what's the answer? So the one I wrote here, 1 milli, is just how to say some theory part. Okay, when we need to convert 1 milligram, we need to convert a kilogram. Okay, so that's the purpose Miss wrote here as a 1 milligram. So we can get 0.0009998 Newton. So later you can check, okay, how many zeros that you have. Okay, so once you're done, you substitute, you match with your force equations with the force equation that we have here based on the charge calculations. So the first thing you converted, you get the answers of the force answer. Okay, so it means 9.8 times 10 power of 31 times with the Newton. So you get the answer. Okay, you can come out like I just put as a A. You get one answer here. Okay, once you get the force, you substitute the force, this equation or this answer into the next equation, this mathematics equations. So once you compare, it means you already get your answer. Force is A. Example, I wrote here as a A, which is equal to this equation, K times with the charge divided by the distance. Okay, so you substitute the value as I let you know, the K constant value. Take note, all the value okay, until we finish the semester, take note the constant value you need to remember, you need to know. Okay, so example for the charge part, K constant is this the value. Okay, power of 9. After that, based on the charge, so they're not specific for you. Charge number 1 is how much the value, charge number 2 is how much the value, unless they specific for you. Okay, then electron is 1.6, then they let you know the positive electron is 10 for. Okay, example I put 2.5 times power of 19 example. So you have 2 charge, so that's the time you need to do write down as a charge 1, as a charge 2. But the question that we have, they already specific for us, the electrons are the same. Okay, the same electrons. Okay, they not point out for us positive ion or negative ion. So that's the reason we square root. Okay, so maybe some of us, Miss, why you square root? The reason because the electrons are the same. Or you can do like this also, 1.6 times 10 power of minus 19 times back. Okay, a category this is a Q1, category this is a Q2. So 1.6 times with 10 minus 19. Okay, so you get the same thing. So you get the same thing. All right. So that's why I use a square root here. So once you're done, divide by the R2. Based back on your equations here, or distance R2. So as usual, how you calculate your maths, the normal calculation, how you did your maths. So at the final part, okay, the final step, you will get the answer for the R. Okay. So even though they shows you R power of 2, our purpose, we just want to find the distance. Okay. So when your power, you bring up to the next side. Okay. Of course, you're going to be a square root. So once you do a calculations, math calculations, you get the final answer 5.08. Okay. Your distance, this the distance will be. Okay. So that's the one I want you to have a look. This is the first one. This from the slides. This from the slide. Okay. Even Miss have other questions. Okay. But it's not from your slide. It's from the reference book. Okay. The second. This is the second question. Okay. It's also from your slide. Okay. But I leave it the task for you for today class because I already dragged too long. Okay. And some of you prefer to finish the class earlier. Okay. So number 2. Okay, and also number 3, I want you to do by your own. Try. Okay, you write your answer in a piece of paper, then paste it in the OneNote, or you can send to me on next week. Okay, we have some short discussions. Okay, so take note, number 2. Okay.
Miss, can I just do the homework in the OneNote, the homework
Can.
there? Okay.
Can, no problem. You can do it. Those okay, some students they able to do by using OneNote. Those not able to do with the OneNote is okay. You write in a piece of paper. Okay. If not mistakenly, 1 milligram equal to 1. Yes, micro 6 kilogram. When you converted your Newton. Okay. So make sure your answer you need to convert in a Newton. Okay. I hope not mute. Okay. Just have a look. I want you to do number 2. Okay. Number 2. Even though you have the answer, as I let you know, not necessarily the answers in the slide, they provided the right answer. Okay, but usually will be the right. Okay, but don't have a look on the answer. You try to do based on the step. Okay, That is number 2. And number 3, okay, even I have one more question, but I think we don't have time. Miss Khan occupied right now. Okay, I have one more question. This from the reference book. Okay, never mind. Maybe we discuss in the next class. Okay, please do it. I want you to do. Okay, and the next one, I want you to go on with, okay, this one we completed during the class. Okay, this is basic electrical quantity. Okay, you need to use Ohm's law. Okay, some of the thing you need to use the basic formula, what you have here. This basic formula. Okay, Miss repeat back. Remember, each of you, please remember the formulas here. Okay, remember the formula. So your task for today, okay, I want you to do this one, number 2 and number 3. And the next one, I want you to do this one, a basic electrical quantities. Okay, number 1 until you have 5 questions only. Try to do. Just try and to do. If you can't do, then it's okay. We can discuss for the next class on the Friday class. Okay. Let me stop record here.